All right, so in this video we're going to talk about multiplication. All right, so we're exclusively focusing, remember, on what we called natural numbers. These were 0, 1, 2, 3, 4, 5, and on and on. All right, and we learned about addition and subtraction. Now, when we talk about multiplication, first of all, let's talk about how we express multiplication. We have a number, and some people will put an X like that. That's what it means when they want to multiply two numbers. You'll also see people put a dot like that. All right, or even the most compact is simply to scrunch the numbers next to each other, maybe with parentheses like that. So all three of those mean multiplication. Okay, what is multiplication? All right, you can think of multiplication as a abbreviation for several additions. We all know what addition is by now, hopefully. Okay, and so think of 2 times 3. Think of that as you're adding two threes together. All right. If I was to do, let's say, 5 times 3, well, that means I'm adding 5 threes together. All right. And we know how to add, so that means multiplication is going to be no problem, right? So think of it, it's just an abbreviation so that we don't have to write a big long addition. All right. Now, because multiplication is just addition in disguise, it's going to turn out that multiplication is going to have all the same properties of addition. Remember when we said that addition was commutative? And remember when we said that addition was associative? Well, it'll turn out that multiplication also has those two properties. Now, this may not be that obvious. Right now, I wrote out 5 threes. Okay, watch this. So that's, if I was to add those 5 threes, that would give 15. Okay, now, it might benefit you to actually work this out, but does 3 5s also give the same? So that would be 5 plus 5 plus 5, and convince yourself that that's also 15. And any other multiplication you can think of with natural numbers, if you flip the order, you'll see that it also gives the same value. All right. So multiplication is commutative. What does it mean to say that multiplication is associative? All right. Well, with addition, let's first review what we meant when we said it was. That means that these two are the same. It doesn't matter the order that you add them together. Okay, so with multiplication, the similar idea is that if you do these if you multiply the 2 and the 3 first, you get the same result as if you multiply the 3 and the 4. All right, and that, of course, not just for these numbers, but it works for all natural numbers. So let's work this out and convince ourselves that that's true. So 2 times 3, that's 6. So this would give 6 times 4. And then the other one would give 2 times 12. And the way that I got the 6 and the 12 was, again, you add 3 threes together. Two in the first one, 2 threes, 3 plus 3. And the 3 times 4, you do 4 plus 4 plus 4. All right, and then now you could do the repeated addition again, and you'll see that they both give 24. All right. Now, what about if somebody asks us to multiply by 0? 0 times, let's say, 7. All right, so how many 7s are we going to add together? Well, we're not going to add any of them together. All right, so that's one way to understand that 0 times anything is going to be 0 because we didn't get a chance to add anything together. All right. Now, the last thing I want to do is I want to review the column method of multiplying large numbers. Now, you could do multiplication for single-digit numbers, Okay, single, so 8 times 7, 7 times 9, 8 times 8, 7 times 6. You could do these, you could do the repetitive addition in your head, but of course that would take a long time. Because these single digit multiplications come up so much, you probably memorized your what's called the times tables. So I highly encourage you to memorize all the single digit multiplications like this. Okay, if you've done that, that'll make it easier then to quickly or more quickly do multiplication with bigger natural numbers. All right, so let's say I wanted to do 27 times 36. Okay, so just to review, what we're going to do is it's similar to what we did when we added and subtracted big numbers. We're going to uh, we're going to have, remember the columns, and we're going to move when we have too much in one column. We're going to add to another column because the other column um, it represents a different amount. So maybe an example would probably be the best way to explain this. So 6 times 7, you can work that out and see that it's 42. So 42 is 2 and 4 packets of 10. So I'm going to put a 4 here on the tens column. 2 times 6 is 12, all right? But 12 plus 4 is 16. So now when I said 2 times 6, you're actually doing 2 packets of 10 times. So 6 times 2 packets of 10. So it's not actually 12 that you're getting, but you're actually getting 120. And so when you add 40 to 120, you get 160. So at the end of the day, you end up putting a 1 and a 6 next to 2. All right? So hopefully this is just reviewed for you. And then you do the 3 by putting a 0, 3, and then the 4 is not there anymore. We don't need to worry about it. 3 times 7, 21. That, of course, means 210. So that's 1 packet of 10 and 2 packets of 100. 2 times 3 is 6. 6 and 2 is 8. Now we add those numbers together and we get something like that. All right.